Well, hello Internet, and welcome to part 10 of my Learn to Program series. In this part of the tutorial, we will focus in on inheritance, polymorphism, and magic methods. If you haven't watched any of the previous tutorials, you should probably watch those first, and I provide a link here so you can do that, otherwise you might be confused. And as well, in the description underneath the video, I have links to all of the code used in this tutorial, as well as a transcript of everything that I talk about, and I have a lot to do, so let's get into it. Okay, so here we are. So when we create a class, we can inherit all the fields and methods from a previously created class, and this is called inheritance. So makes a lot of sense. And the class that inherits is going to be called the subclass, while the class we inherit from is going to be called the superclass. So what we're going to do here is I'm going to create different types of animal groupings, and animal is going to be my superclass. So what I need to do here first is to come in and define my initialization method, and then inside of it I am going to define different classifications of animals. So I'm going to have something like birth type, which means are they born in an egg or are they born live, and I'm going to put unknown in here as a default. And also we could have appearance, so it could be things like does it have fur, or does it have feathers, or whatever you'd like. And then finally I'm going to have blooded. I don't know if any of these are technical terms or not. I'm just doing this way. And then I'm going to create reptiles and mammals, and we're going to see how they differ. Okay, so now we need to come in here and set these up, and once again, self is a reference, just like you would refer to yourself as my. Self is a way for objects to refer to themselves that don't have a name yet. And we can put appearance inside of here as well. And just want to make you guys well aware, I answer every question that YouTube sends to me. So if you have any questions, leave them in the comment section below and I will answer them, because I want to make sure everybody understands what's going on. And make sure you spell appearance correct. There we go. And now I'm going to define my getter method, and we do that by setting different fields up as properties. So I'm going to first come in and cover birth type, and make sure you put self inside of there. And whenever we return the value for this, make sure you say self with 2 underscores and birth type in this situation, so that that works for you. And then we will define our setters by going at and birth type once again, and this time we're going to say setter and define, and then we'll put birth type inside here again, and birth type is going to receive self as well as the birth type that we're going to be changing it to. And then whenever you want to set this, you just go self once again, and again remember the double underscores, and then birth type, and then assign whatever birth type was passed inside of it, and that's all we need to do for that. And then we need to do exactly the same thing for appearance as well as blooded. And I went ahead and did that. So we come in here and do appearance. And remember, you can hit pause on these videos at any point in time. And I typed in exactly the same styling here for the property for appearance as well as the setter. And then here we did the same thing for blooded as well as the setter for blooded. Now we're going to get more into magic methods here in a moment, but I wanted to show you a magic method here right now. And this is the string magic method, and it can be used to cast our object as a string, which means if somebody just types in print and whatever the animal name is, the animal object is, it's going to print out a certain very stylized version of information. So to define this, we just go define 2 underscores str and 2 underscores. That's what sets this off as a magic method. When it starts with 2 underscores and ends with 2 underscores, you know that is a magic method. And it gets self as well. And then you need to define the string that is being returned. So I'm going to say something like a, and I'm going to put all of the information inside of here that we have about our animal. Is, and it is, and it is. And then those are the 4 things that I'm going to output about this. And the first one is, of course, I'm going to be using format here for this guy. Very first thing, if you want to actually get the class's real name, what you do is go type, and then you'll say self. And then outside of this, you're going to put a dot and 2 underscores and name followed by 2 underscores, and you can see it went to the next line there. And that's one way to get the class name. We also want to get the birth type, so let's go and get birth type. And we also want to get appearance, and then finally we want to get blooded. Okay, so that's going to take all of this information, and whenever the user tries to print out our object on the screen, it's going to throw all that information into these nice little parts here using format, and then output a string onto the screen. So there's your first magic method, and I'll show you some more here in a moment. Now we want to inherit every getter and setter and method in general that is inside of the animal class in a new class that is called mammal. And to do that, we just go class, and we define the name for it, and then you could put animal inside of here, and you could put more things inside of here if you had them. So let's say you had a reptile class that for some reason you wanted to input all of the methods into that guy. That's how easy. You just put a comma there, and you can import multiple different classes into this one class. Then of course we need to still initialize this, so we're going to do that. And this guy is also going to be receiving the birth type. And just to keep this simple, I'm going to define all the things that separate mammals from just generic animals. So I'm going to say it is born alive, and we can also say, go down to the next line, we can also say that the appearance for a mammal is going to be hair or fur, and also we can say blooded is going to be equal to warm-blooded. And then finally we can also say something that separates mammals from other different types of animals is how they nurse their young, and the fact is that that is true, that mammals do nurse their young. Now what's neat here is we can call the initialization method inside of animal from inside of our new mammal class that we defined. And how we do that is we just go and define the class we want to call and the method specifically we want to call. And don't forget to put self inside of here. You have to put self inside of there. And then we'll just pass in all of the things that the animal initialization method can handle. So it can handle birth type, it can handle appearance, and it's also going to be able to handle blooded. We can't pass nurse young inside of there though, because that doesn't exist in animal. And then after we do that, we can say self, and how this differentiates, we go and do nurse young on its own, and if information on how the mammal's nurse is in there, then we can put that inside of there. Another thing we need to do though now, since we have nurse young inside of there, is we need to set that up with the getters and setters. So let's go and copy that right there and then paste it inside of here, and instead this is going to be nurse young, and then this will be nurse young as well, and this is going to be nurse young, nurse young, and nurse young, nurse young, and finally nurse young. Okay, so those are all set up for the new mammal class that we defined. Another thing that is important to know is we will also be able to overwrite any methods that are inside of the classes that we inherit from, and they will automatically take effect. So let's say that we want to overwrite our magic string method. No problem, define, and we can get that guy right there with self. And of course, well, if we want another way that we can call for a method to run in another class is to type in super, because that's the super class. Animal is the super class and mammal is the subclass. And then we would just go and reference that magic method. And that's going to give us everything that we need, and then we'll concatenate the string that this guy throws back with our new information that's going to talk about nurse young, or nursing young. So we'll say and let's put a space inside of there. It is, and then we had true or false, so we're going to say true, they nurse their young. That on the end, and we'll go format, and then we can just go self. And in this situation, you don't put the double underscores though, you just type in nurse young like that. Another thing that we could do here is we could go and put, let's go and put this right here. If we want to extend our string across multiple lines, we can put a double quote there, and then a slash, and then down here like that. and that's going to allow us, a backslash is going to allow us to continue that string onwards. All right, so there's another neat little thing that just came up there, and I thought I'd cover it. So there we went and created our mammal subclass of the superclass type animal, and you can see exactly how all that is all set up there. So let's go and create another class, and this one's going to be called reptile, and it's also going to inherit everything from animal. And we could do pretty much the same sort of things that we have here. Let's go and find this guy. We're not going to worry about nurse young this time though. Paste that inside of there. Birth type. And here we're going to change the birth type to born in an egg or born alive. And appearance is going to be dry scales. And then blooded is going to be changed to cold-blooded. And here we'll be able to just simply call the animal class and have it initialize everything. So we'll say animal and underscore, initialize that, and make sure you pass self inside of there. And then we just pass in all of our different things. So birth type and appearance, as well as blooded. Now I want to talk about something that is called function overloading, which is very common in other programming languages, especially object-oriented programming languages, but it really doesn't make sense with Python. So what I'm going to do is I'll just demonstrate how overloading works with other languages. Now with most programming languages, not Python, and Python's awesome, and that's why it doesn't matter. What we would have to do here is, let's say that we wanted to have a method that received an unknown number of values. Well, because in most programming languages you need to do things like define that you're going to receive 2 integers and a string, meaning you need to define that yes, we're going to definitely be receiving an integer first, then another integer, and then another string or a float or whatever, and you have to be very specific about what the data type is that you're going to be receiving in your function. If you would want to receive a different number of attributes or parameters sent into your function, what you could do in other languages is you could come in here and actually create a different version of SUMAll that says, for example, maybe it receives another integer. So it's going to add 3 integers versus adding 2 integers. That is how operator overloading works, or function overloading works in other languages. And we differentiate the version of SUMAll that is used based off of what these parameters are. In Python, none of that matters, as you know, because you don't need to define the data types that are being sent inside of here. So instead, inside of Python, if you would want to receive an unknown number of variables passed inside of here, we would use our old friend splat once again, which I talked about in a previous part of the tutorial. And then you could just come in here and say sum is equal to 0, and for I in, remember, you don't use the splat whenever you refer to args outside of that. And then we could just say sum is equal to I and sum all those guys up and then return sum. So that's another way that Python is really cool, because you don't need to use function overloading. You can just go and receive an unknown number of values and they will just work out for you. Just wanted to cover that just in case somebody had any questions about that. Alright, so now that we created all of our different classes, let's come in here and use them. And we'll come down here and call for our main function to execute. Now if we want to create a new animal type, we can just go animal1 is equal to, call our animal class, and then inside of it we can pass just one thing just to show that it works. So there's born alive, and because we went inside of here and we passed, or we defined default values, we don't need to define them all. So we can define birth type but not define anything else, and it's just going to work for us. Okay, so we'll say that we have an animal and it is born alive, and if we then want to call for this function to execute and give us information, we can come in and get a specific thing like birth type, Control R, oh, gave me an error, let's see what I did wrong. And we come over here and line 61, it says I did something wrong, let's come up and fix it. Oh, it's saying invalid syntax. These errors that they give you in Python are terrible. I could tell exactly what I did wrong. I forgot to put the colon inside of there. So now if we run it, it says animal is not defined. Let's come in here and look and see what's going on with this. 36. And it gave me that error because I didn't have indentation set up properly. So let's go and set that up properly so that that all works. And actually, this is a nice thing because we can come in here and show you how PyCharm can automatically correct any of your indentation errors. We can just go to code inside of PyCharm up here and reformat code, and everything's going to line itself up real nice and neat. So let's see if that went and corrected that. Oh, geez, got another error. Okay, so going over a whole bunch of ways to fix errors, let's go into line 10 and see what I did wrong here. And it says line 10. We look down here at line 10. Don't see anything wrong with that. But if we will go up here and look at this guy, we can see that line 10 is incorrect, or line 4 was incorrect. We put in birth instead of birth type. All right, now let's run it. And we get born alive printed out. Okay, so a couple errors. Sorry about that. Sometimes I make them. And let's come down here and let's play around with our objects we created a little bit more. So all that did was it went in and got us the birth type that we asked for or that we already set. And why don't we come in here also and call our string magic method and see what that looks like if we pass in our animal1 object inside of there. And what I mean by that is this guy right here. This guy is going to print out all the information about our animal object that we created. And we can just go Control R, and there you can see a animal is born alive, it is unknown, it is unknown. So it went through those default values in there for all the things that we didn't know about the animal type. So now let's go and let's create a mammal, and we'll see, let's throw a print inside of here just so we can divide up the animal objects from our mammal objects. And to create a mammal object, we just come in and call mammal, of course. And inside of this, well, let's just go and create it just like that. Well, we'll just leave it like that since we set good default values for our mammals already, and then we can see what they come out like. Once again, if we want to get those individual animal or mammal parts, we can just reference those different values that we have there for us. So we can get birth type, and we can also come in here and get the appearance for our mammal. And we can also get our blooded type as well as the nurse young part. And there we are. And you can see once again, born alive, hair or fur, warm blooded, true comes back. And then once again, we're going to be able to come in and call our string function on our mammal. And it's going to give us a nice sentence with all that information. A mammal is born alive. It is hair or fur. Well, I should have changed that to has. Hair or fur, it is warm-blooded, and it is true they nurse their young. We were able to come in there and it automatically used all those different attributes and properties and methods that were defined inside of an animal for our mammal class, just to show you how that works. So now we'll go in and we'll create a reptile object, and we can look and see how that might differ. So we could say, let's just call this reptile1 is equal to, and we'll call for the initialization of reptile. And once again, of course, we're going to be able to print out information about our reptile. So we can say birth type, for example, and you can see born in an egg or born alive gets printed out there on the screen. And then once again, finally, we can go and print out the whole entire thing using our magic method. And here you can see that it works. A reptile is born in an egg or born alive. It has dry scales and it is cold-blooded, prints out on the screen. So pretty cool stuff. And let's also go and demonstrate that our reptile SumAll, it's a very smart reptile that knows how to add. Let's go and show that that indeed is going to work. So we'll say sum, and then we'll use format here to throw this inside of here, format, and then to call that specific reptile method, just go reptile1 and SumAll, and then inside of here you can throw as many different values as you would like. And if we run that, you're going to see the sum is 15, just like you might have hoped. And that brings us to polymorphism and how it differs inside of Python versus other different languages. Now, polymorphism in Python works different from other languages in that functions are going to accept any object and expect that that object is going to be able to provide the needed method to execute. And this really isn't something to dwell on. Just know that if you call on a method for an object, that the method just needs to exist for that object to work. That isn't necessarily true with other programming languages. And the technical reason why is that in most programming languages, you're going to define the data type whenever you declare the variable. And that is called what we call statically typed. That means when the variable is defined inside of Python, if you want to create a new variable, so variable 1 is equal to 10, well, it's an integer right now, but you could just as easily come in and throw a string inside of there, and now it's a string. Inside of most programming languages, you need to say this is an integer, it's called variable 1, and it has a value of 10. You can't then turn around and throw a string inside of there, or the programming language is going to flip out. Now, I'm talking about languages like C++ and Java. Inside of Python, it doesn't matter, and that's the reason why polymorphism isn't such a big giant thing. And specifically what I was saying here before, languages like C++ and Java are statically typed, or the type is defined at the declaration of the variable, versus in Python, variables are going to be dynamically typed, meaning that the type is defined when a value is assigned. And, doesn't matter as much. So I'll demonstrate polymorphism inside of Python. I'm going to create a function here called getBirthType, and it's going to receive some object. Doesn't know what type of object, but it's going to do its darndest to work whenever it does receive it. And whenever it does receive it, it's going to say something like the blank is blank, and we'll say format. And we can come in and do type for the object, and this is going to give us our class name. And then we can just go underscore name, double underscore again. And let's go down to the next line here, and we'll say something like the object followed by birth type. Okay, so we went and defined this new function, and let's go and grab it, copy that, and we'll throw it outside of main. So we'll paste it inside of here. So there is that same exact function, and then I'm going to use that function with different objects, and you're going to see that it just works. So get birth type and pass in mammal1, and then get birth type, and this time I will pass in reptile1. And if we run it, of course, you're going to see the mammal is born alive and the reptile is born in an egg or born alive. Okay, so that is how polymorphism works inside of Python. Really, it just works. I mean, as long as the method exists whenever you call on an object, just like we did here. So if birth type exists inside of your object, no matter what the object type is, it's going to work. In other languages, that would be more magical. But in Python, Python's already magical enough, and things just work, and it's easy to work with. And that's one of the reasons why I consider Python to be the perfect language for a beginning programmer. Okay, so enough about inheritance and function overloading and polymorphism. Now let's take a look at something really neat, which are magic methods. Now, as you saw previously with the initialization method as well as the string method, magic methods are going to be surrounded by double underscores. And we can use magic methods to define how operators like plus or negative or multiplication, division, equal to, greater than, well, this is multiplication, greater than, less than, greater than or equal to, and so forth work. And you can see here an example of a couple of those. So just like we used init for initialization and str for string, if you wanted to be able to compare custom objects in custom ways, you could use equals here, not equals, less than, greater than, less than or equal to, greater than or equal to, add, subtract, multiply, divide, and modulus. And I'm going to show you here an example with a custom class on how we can do that. So what we're going to do is we're going to create a custom class, and it's going to be called time. And we're going to come in and define how this is going to be initialized. And you could pause the video and give this a go to see if you create your own time class. Otherwise, I'm going to do it. So I'm going to say that hour is going to start with a 0, and minute is going to start with a 0, and second is going to start with a default value of 0. Then inside of it, just like you're probably guessing, we're going to be able to go hour is equal to whatever the hour was that was passed inside of it. Do the same exact thing for minute, and do exactly the same thing once again for second. Alright, so we have our time class, and that is how we're going to initialize this. And this is going to be military time, meaning that I'm going to use 24 for hours. So, very first magic method, you've already seen this. This is the string magic method. So string just like this, and we just define inside of here what strings returned anytime our function is called for, or our object is called to print. And I'm going to say that I want to return. I'm going to do this in a way so that I can demonstrate something else. So we're going to say this is going to represent the hour. And then if I want to come in here and I want to have the minutes, but I want them to have leading zeros so that there's always 2 digits returned. Even if it's like 1, it's going to come back as 0, 1. I just go colon 0, 2, D like that. And that is going to make sure that that comes back as 2 digits minimum, so it doesn't look silly. And do the same thing for our seconds. And then outside of this, I'll say format. And then inside of the format, I will say self hour, self minute, and self second. So there we are. Defined all those guys, and let's just go and put this on a second line. And there we are. Okay, so there is a magic method that is our string function. You already saw it. So now what I'm going to do is I'm going to create the same thing for add. And then I'm going to define here what exactly happens whenever we try to add 2 of these times together. So I'm going to say other time that we're going to be adding to this guy. And then inside of it, I'm going to define something called new time, which is going to be the sum of these times. And I'm going to call you can actually create objects inside, of a specific class inside of the class itself, which is really cool. And now you can pause the video, and I want you to work out exactly how we would work with 2 different time objects and how we could add those together. All right, so hopefully you came out with a good idea here. Basically, I'm just going to make some notes on how I would do this. So what I want to do is I want to add the seconds and correct if sum is greater than 60. And then the next thing that I want to do is add the minutes and correct if sum is greater than 60. And then finally, we're going to add the hours and correct if sum is greater than 24. All right, so we have all of those set up, and now we're going to come in here and create it. So I'm going to say something like if self second plus other time second is greater than 60. Now I need to decide what I want to do. Well, I want to increment the minutes. So I'll say minute plus equal to 1. And what else am I going to have to do? Well, I'm going to have to add the new time now for our new time that we're defining here. And how I'll do that is say new time second is going to be equal to self second plus other time second. And then inside of here, since I incremented the value of 1 for the minute, well, then I need to subtract that out. So I'll subtract out the 60. Else, if we didn't have a situation in which the sum of those 2 values was greater than 60, actually it should be greater than or equal to 60. Caught a little bit of a bug there. And now let's come in and say new time second is equal to self second minus other time second. And now I need to do pretty much identically the same exact thing for our minutes. So I'm just going to copy this and paste that inside of here. And instead, what I'm going to say is minute. Make sure I have minute up here and not minutes. Yes, I have minute, minute, second, da 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 da. That's good. And minute. And this right here is going to be changed to hour. And this is minute as well. And change all these other guys over here also to minute. And just so I can say minute again, here's a couple more minute changes, and there we go. So there we went, and we created that. And now I need to come in here and do something similar with hour. Now here what I'm going to say is if self hour plus other time hour is greater than 24. Here I'll go new time, and I'm just going to keep this simple. I'm going to expect that they're not adding large numbers of times and so forth, like that's going to throw me way over 48 hours and things like that. So I'm just keeping this simple. I'm just demonstrating how to use the add magic method here. I'm not trying to make the absolute perfect method. So here we can go self hour plus other time hour, and then outside of that subtract 24. Else I could say new time hour is going to be equal to self hour plus other time hour. And then this is very important. You then need to return whatever the result of this is, which is going to be our new time object. And then down inside of here, we can create our main function, and we'll create our time. So we'll say time 1 is going to be equal to time, and we'll throw 1, 20, and 30 inside of there. And we can print this out just to make sure our string magic method worked out for us. So there's time 1. Let's run it. And it didn't print out. Let's go up here and see if we can figure out why that might have been. Oh, I know why. Because I didn't put main down here. Boy, I'm making seriously silly mistakes. Okay, so there that goes right there. And let's go and create another time. Let's call this time 2 is equal to time. And here we'll say 24 to make sure that the hour increments. And we'll change this to 41. And then we'll change this to 30. And we'll see how those work out to check our magic method out. So we'll go print, and we can say time 1 plus time 2, and know that that's going to work. And there you can see that it indeed did. Okay, so pretty cool stuff. And for homework, I think you guys should go in there and get the time objects to work with some of the other mathematical and comparison operators. And that should be a fabulous exercise. It's going to teach you a whole lot. And just like always, please leave your questions and comments below. Otherwise, till next time.